So we're going to finish our talk about these sketching the graphs from various situations and things. Okay. And today we're going to focus again on domain and range, so identifying domain and range of these things. Also talking about discrete versus continuous. Okay, discrete and continuous too, graphs. There are two different kinds of graphs that you'll see. And then so let's take a look here. So we're continuing from what we already talked about here. Some graphs that represent real-world situations are drawn without any interruptions. Okay, in other words, they are continuous graphs. So if you look up here, right, there's no interruptions. It's just one smooth graph, okay? These are all continuous. There's no jumps, there's no holes, there's no gaps or anything like that, or breaks or anything like that. A continuous graph is a graph that is made up of connected... Mark, can you get your head up, please? Thank you. A continuous graph is a graph that is made up of connected lines or curves. Connected lines or curves. Other types of graphs are not continuous. They are made up of distinct, unconnected points. These graphs are called discrete graphs. Okay? So only the kinds of graphs that are made up of distinct, unconnected points are known as discrete graphs. Continuous, you get the idea of continuous. Discrete might be a little bit harder to see. There's an English word, we use the word discrete when we're talking about you need to be discrete. That means you need to be kind of on the DL or quiet about it, kind of secretive or whatever, okay? But I know DL is an old phrase. You guys don't use that anymore. You probably have a much cooler one to say, but you get the idea, okay? Discrete. Discrete in this case is not that, though. It's just individual points being graphed like that. And different situations would call for discrete graphs versus continuous graphs. So, for example, a student is taking a test. There are 10 problems on the test. For each problem the student answers correctly, the student received 10 points. So you can see here on the x-axis, okay, is the number of problems they get correct. And then here on the y-axis, it's the number of points they will receive. So at one question, they get 10 points there, right? At 2 questions, 20 points, 3, 30, 4, 40, 5, 50, so on and so forth. Does it make sense to connect these dots?
Yes.
Should we connect them? Okay, so Sky, why do you say yes? What do you mean? Why should we connect them?
Because it's his rate of the points and questions.
True.
His rate, but it is.
Okay.
Because we don't know what he got right and what he got wrong.
Well, that's true. That's true. But my question would be this. So if we connect the dots, that means that there's points all in between these two that I already have graphed, right? So if you connect it, you're showing that not only if I get 1 point, or if I get one question right, I get 10 points, and 2, I get 20, but if I get 1.5, I would get 15 points. But is there a partial credit in this case, Matt?
No, but my other thing was that, because isn't it only time could be continuous because there is different increments of time?
Right.
But other stuff is really not.
Right, yes, exactly right. So we have to be careful, and I will admit that some of the problems that we did, we treated them like they were continuous, right? But really they're not. I mean, for example, the population of people entering a hockey game, it's not really continuous. Either there's a person that's in the game or a person that's out of the game. You don't have parts of people entering the game. They're either in or out kind of thing, right? We really count them, as fractions. Even if, they're just stepping in, I get it, we could argue that. But in general, a person is a person, right? No matter how small. That's Horton anyway. Okay, so in this case, right, we wouldn't connect these dots because we don't get points between these two. If you get 1, you get 10. If you get 2, you get 20. If you get 1.5, there is no way to get 1.5 here. It's either right or wrong, okay? I know Mr. Wade sometimes gets partial credit and stuff like that. But in this scenario, it wouldn't make sense, okay? Now, we already did letter B. If you turn the page there, please, okay? We already did letter B, but we skipped talking about the domain and the range there. Actually, you know what? Before we jump to domain and range, I want to get some practice with that discrete stuff. So let's take a look here at number 6. We'll do that first before we talk about domain and range. Okay, so number 6 there. Okay, and again, I know you guys already have number 5 filled in. I am using a different paper here, so that way we have this space. All right, so number 6, it says a local salesman is going door to door trying to sell vacuums. For every vacuum he sells, he makes $20. He can sell a maximum of 10 vacuums a day. Okay? So, what would be some points here that we could plot? So, for example, If he sells one vacuum, okay, Hannah, how much would he make?
$20.
One vacuum would be $20. So one vacuum, $20. We'll put a point right there. Okay. Is he going to be able to sell 1.5 vacuums, Hannah? No, it wouldn't make sense, right? So we're not going to connect these dots. We're just going to have these discrete single points here. Okay. Let's go to, let's see here. Oh, someone who's here. So Tyler C., if he sold 2 vacuums, how much money would he make? Sorry. Go ahead again. 40, exactly right. 240. And you guys get the idea. 3 would be 60. 4 would be 80. 5 would be 100. 6 would be 120. 7, 140. 8, 160. 9, 180. Yes, there is a pattern, isn't there? And we'll talk more about that in a little bit. A 10. And then, do I need to graph for 11? Why not? You can sell a maximum of 10 vacuums a day. Right. So that would be the graph, okay, of his earnings, okay, for selling the vacuums. Okay? Is this continuous or discrete? Discrete. Okay? Now, I'm going to tell you guys, days or weeks from now, we're going to graph equations like this, okay, situations like this, and we will connect the dots. Okay? We will in those future times. And you could then call it continuous if you wanted to. But we also want to think in the context. Does it make sense that you can sell part of a vacuum? The answer is no. So we might be moving back and forth between whether this relationship here is continuous or discrete. Okay? But for sure, if you see these individual dots, it's discrete, right? And in the context, it really should be discrete. Even if we do happen to connect the dots, it really should be a discrete relationship here because they're not connected. Okay? They're separate like that. Okay. Questions on the discrete? Does that make sense? So continuous, connected, discrete, not connected. Disconnected. There we go. Discrete, disconnected. Okay? Continuous, connected, discrete, disconnected. Okay? And just individual dots, really, because you can be disconnected and not be discrete. So, individual dots. Okay. Let's go back then to what we talked about before with letter B here. I want to talk about domain and range, too. Identifying the domain and range, the inputs and the outputs of these graphs as well, because we talked about that some here earlier. Okay, so let me pull this up here. I think I got it. Yeah, I do. Okay, so here's the one that we did earlier. There it is. Okay. So now that we know what we know, okay, this graph is someone who's here. Tyler L., what kind of graph is this? Is it continuous or is it discrete?
It's discrete.
How do you know?
Because it's not in a pattern.
Oh, okay. Okay, I see what you're saying there. Do we have to be in a pattern, folks, for something to be discrete or continuous? No, it doesn't have to be. Okay. What do we look for to determine if something is discrete or continuous? Whether what is true, Matt? If it's connected or not. Okay. So, Tyler, are these dots connected or not? So that means it is discrete or continuous. It is continuous. Very good. Okay. But Tyler, I'm glad you still said that, the earlier stuff too, because now we can fix that. That's okay. All right. It's okay to answer. If you're not sure even, we can fix those. Okay. Continuous though. And do you understand why it's continuous now, Tyler?
Yeah.
Because the dots are connected. Okay. All right. The points are connected, I should say. All right, so let's continue here then. So we'll look at now this graph, and we want to describe its domain. Okay, so the domain here, it describes all the inputs. Okay, it describes all the inputs. Now, because it's continuous, we don't have a number of dots we can just count up like we did before, right? In the earlier graphs that we did, we could just say, okay, 0, and then 10, and then 15, and then 20, and it looks like 35, and then actually those are a little bit off. I remember now. Yeah. Anywho, okay. So my point is though, we don't have just a bunch of dots. It's like a whole graph here. It's all connected. The domain is going to be actually an interval here. Okay. What is the smallest input value that we have here? Kendall, what's the smallest input value that's shown on our graph? Yeah, the smallest, that's part of our graph, I should say. What's the lowest value? So look at the graph. Consider the entire graph. Okay, look at the entire graph right here. From here, okay, like this, and down to there, okay. What is the lowest input?
0.
0. Yeah, it starts at 0. Okay, so we're going to start at 0. Okay, and do we actually get to 0? I mean, do we actually like include 0 here? We're going to include it, okay, because it's part of our graph. So we're going to put that square bracket. So we are doing interval notation here, folks. Interval notation. Okay. Now, what's the highest that our graph goes? And this one's a little bit tricky because we had to do some math here. So let's see. I'm going to try and help us figure this out. You can see that it goes just beyond 45 here. I think it was 47 is what it went to. Because let's see here. It was 10 minutes. And then pull the plug, 15 quarts in 5 minutes, so that'd be 15 minutes later. Plus 6, so 21. 21 plus 15 is 36, and then 11 more minutes. So yeah, 47. So it's going to go up to 47. That one's a bit trickier to see there. Okay, but the farthest right that we go here is at 47, right there. Okay? And so then we get to that point too, so we're going to include that as well. So that's the domain there. Okay, we're just going to list all the numbers between 0 and 47. Okay, because we hit all that time between 0 and 47. All right. How about the range? What's the lowest output value? So we'll go to Caden there. Caden, what is the lowest output value? And then Matt will be with you in a second. What's the lowest output value, or the lowest Y value, you could say too? Yeah, 0. Okay. And do we actually get to 0? We're going to include it here, right? Because the tub was actually empty. At some point. All right. And then Matt, what's the highest? Matt T. What's the highest Y value that we get to? I think if you look here, I think I might have it graphed. I said the 105 there, right? I think that's what we get. I think we actually get up to that. Okay. So 105. It's the highest Y value there. Okay. So 0 to 105. And we hit every Y value in between, right? Every Y value gets hit in between there. Some, we have to go like that, but we eventually hit every Y value between there, and then every Y value on the way down too. Okay. So let's take a look at the next one, our snowstorm problem that we did. Okay, let's try that one too, because it also says, tell whether the graph is continuous or discrete. So we'll look at that one, number 5. Okay, so Catherine, is this graph continuous or discrete? Continuous. Very good. Okay, and how could you tell it was continuous?
The lines are connected.
Yeah, the dots are connected. Very good. Continuous. Okay, let's talk about the domain then. Okay. Domain, again, deals with the inputs, the x values here. Catherine, where do our inputs or where do our x values start? What's the lowest x value we've got here, Catherine?
0.
0. Okay, and we do start at 0, so we're going to include that 0. Okay, very good. And then let's go to Carson. Carson, what's the farthest that our domain goes, though? What's the greatest value that our domain takes? What's the biggest x value that we have shown graphed? 8. Yeah. Okay, so we're going to go to 8. That's our domain. Okay, 0 to 8. All right, very good. And then Alex, for the range then, remember range describes the outputs or the y values. What's the lowest y value here, Alex?
I would say 0.
You would say 0, and you would be right. Okay? And Alex, what's the highest y value or the highest output value?
I just said 5.
Yeah, it's 5. I think it goes to 5.5, I want to say. I could be wrong. I might have graphed that incorrectly. Let's see here. 2 inches an hour for 2 hours, that's 4, plus another inch, 5. You're right, it should only be up to 5. I graphed it a little bit too high yesterday. I was not doing a very good job. There should be more like this. So good job.
I have a question about the domain, the highest value.
Okay.
I didn't graph an 8.
I think it does go to 8 though. They ran out. I think they didn't go far enough there. If you look, because it says 2 inches an hour for 2 hours. So that's 2 hours. Slow to 1 inch an hour for an additional hour. So that's now 3 hours. 3 hours after, we're at 6. It began to melt at 1/2 an inch. And then 2 hours later, so 6 and 2 is 8. So it goes out to 8. It tells us information out to 8, but it doesn't give it on the grid there. Again,
But we're putting in the highest x value, the lowest x value, the highest x value, the lowest y value, the highest y value.
mm-hmm.
So even if on our continuous graph, like if the highest value is not, it can be anywhere on the continuous graph.
The graph is there to show the relationship.
Mm-hmm.
It is the domain. It is the lowest x value and the highest x value for the relationship that we're interested in saying for the domain, not like what the numbers on the graph are. The numbers on the graph are supposed to be dictated by the story. They didn't put 8 on here like they're supposed to. So it should be like the whole story that they're, you know. So the fact that the graph only went out to 7. Sorry, the fact that their grid that they provided for us didn't go out to 8, that's on them. That's a mistake. It's an error. It should go out to 8 because they give us enough information for 8 hours worth of snowfall, essentially, or snow behavior, I guess I'll say.
Thank you.
So yeah, it's not very personal. That's the second error we've discovered this, thus far today, right? Matt got that one for the warm up, and then this one. So yeah, I'm sorry, guys. That's what we're dealing with here, but you can still get the idea from it. Okay, we don't necessarily need to be perfect, okay, in order to understand it. All right, and then the last one here. Okay, we already said this was discrete, right? I don't need to calling you guys about that again. This is page 108 is where we are, page 108. Okay, page 108. Okay, so for this case, our domain, we're going to list them out. When you have a discrete function or a discrete relationship like this, we're going to list out those points, okay? So, Shepard, what are some of our x values here that we hit?
2.
Okay, so let's start at the lowest one first. So, yeah, we'll do 0, and I guess 0 at 0, yeah. And then what was the next one?
1.
And then so on all the way up to what?
11.
Actually, we're going to go up just to 10 because I think he only sells a maximum of 10 vacuums there. But, yeah, right idea there. Okay. So that was the range. The domain, we're just listing out all of the numbers of vacuums. Sean? After you answer this question here, yes. So for the range, Sean, what would be the y values we're going to list out here? Starting with? What's the lowest y value that our points have here?
20.
Lower than that?
0.
There, yeah, there's one at 0 there. And then 20, and then what?
40.
And then
60.
you get the idea, right? 60, then 80, then 100, then 120, all the way up to 200 there. So 140, 160, 180, 200. Okay, just like that. Okay. So if it's discrete, you got to list the domain and the range as a list of numbers. Okay. If it's continuous, you're going to do these intervals, the ranges there. Okay, like these intervals for continuous. Okay, lowest to highest, lowest to highest. Okay, sorry, I put that one up. Alrighty, questions on any of that? All right, so I think I'm going to get you guys started then on some practice with this. All right, so it's going to be in your book again towards the end. Let me get this finished here. Okay, let's see if I can find those pages. Okay, so starting on page 112. Page 112, starting there, I would like you to go from numbers 12 to 20. Okay. Oh, actually, sorry. 12 to 23. My apologies. 12 to 23. There we go. That'll fix it. Okay. So I'd like you to work on that here in class. I'll come around and help you guys too if you get stuck or you're not sure you're going to check it. Right? But that's what I'd like you to do. So page 112 in your book, numbers 12 through 23, please. Read the questions, okay? By the way, for number 12, you may want to read some of this information here at the top, talking about children selling lemonade and stuff like that, okay? So, go ahead there, and I'll come around and help as we need it. Okay, just to make sure we're okay. All right, so let's get to work on that. When Sean comes back, yes, you may. Okay. 12 through 23 on page 112. 12 through 23, page 112. Question. Okay, so question here. C and A, aren't they kind of the same thing? Let's take a look. Okay. What do you guys think? Are C and A the same?
No.
Not quite, right? So, but they're close. So, Alex, I mean, I think you can tell me, Alex, like, what is the difference between C and A? One's connected, right? So, in this case, which one will make more sense? They're selling only, they're selling up to, or only 10 cups of lemonade.
I guess A would because it's individual cups.
Exactly. You're not going to sell a fraction of a cup. Okay.
So basically, C and D, they couldn't even put on this. How do you explain?
Say, what situations could the other graph represent? Yeah, to like describe those.
Because they can't fit in this context at all.
You would need like. I'm trying to think.
Time maybe, like how much time?
Yeah, but the problem is, you can see here they gave us the units as well, so we couldn't even like throw a time unit in there. Because I agree with you, Matt. That would be a good way to go, to make it continuous here. The only way I could potentially see you to kind of like trick or like kind of like trick the system here is if you're talking like millions or billions of cups being sold and then their profit, because then these would be there'd be so many points it would look like a straight line. You know what I'm saying? It would like look like a line.
This is kids though.
I agree. I agree. I hear what you're saying. Well, so
They only sell 10 cups.
but be careful though. This scenario is for A and A only. For these other ones that don't work, they say make up whatever your scenario would be. So you could say then, okay, let's say it's like a company that sells cups, and that's their profit versus the number of cups that they sell, kind of thing.
Do these children have a vending license?
That's a good question. Or have they been checked by the state health inspector? Because this lemonade, you guys seen?
I'm incredibly concerned about this.
I don't know if you guys have seen. What's that? Oh gosh, the show on Netflix.
Breaking Bad.
No, the season 2. They just I can't remember what the name of the show is. Anyway, it's probably not appropriate. So American Vandal. There you go. Yeah, season 2 of American Vandal. That's to be appropriate for this one. So, but anyway.
Why did they like the poison lemonade?
2 kids are selling
Yeah, they dumped like laxative in lemonade and like made everyone sick. So.
Well, I mean, like, that's not poison. Poison would be like.
No, but it does
Might
make
as
a
well
mess. So. Anyway.
The lemonade is lactose.
Also, if you do that to someone, but also if you do that, it's very serious too, right? So like, don't go and do that. It's very serious. I've heard that. Yeah. I heard that. I've heard that it has a laxative effect.
Me and my friend were actually gonna do it to one of our friends.
My brother
We changed our mind though.
Good idea.